All right, so we are back from Mr. Jeffrey's Algebra 2 class. We're still looking at polynomials, and we have today is Destinations Day, hence the toga. Yeah, because I'm not going to sit there and like try to flash my chest hairness and such. What, chest hairness? I mean, listen, there's a very small step shh, between like me and like a bear or something. Okay. So, and if you hadn't done so yet, hit the little like, hit the subscribe, hit the bell. So, we're doing transformations of polynomials. The good thing about this is that we don't have a h and k anymore, but we kind of know where they go. All right. So, if we're looking at this, here's our original problem. Okay. And this is what's happened to it. Okay. So this is at the end. So this would kind of look like our K. All right. This means that this is actually down 2. We took this. It's -2. It's just moved down 2. Because if you read these bold words, they're called directions. Describe the transformation. So from here to here, all it did was go down 2. That's it. Super duper crazy hard. Okay. Now, if we're looking at number 2, here's our original problem. This has a -3 in parentheses. This would normally be where our h value is. Okay. I'm sorry, +3. Listen, symbols are hard. The reason why I said -3 is because, yes, this would, you know, yeah, it's the opposite. So it's in the parentheses. This is like our h. So this would go left 3. Okay. So that's all we're really focusing on. We're not worried about stretch. We're not doing like multiple things at once. We're just doing like one thing. Yeah. Well, basically, let's look at it like this. Okay. So, nope. All right. If it was out in front, that would normally be where our A was, right? If it's in the parentheses, that would normally be where our H would be, right? And if it's at the back, that's normally where our K would be. So we kind of got to use our context clues about things that we have done before. Okay. Some of y'all are like, what's a context clue? Is that a website? All right. So let's look right here.
Okay, Mr. Jeffries.
So on number 3, it goes from this and it has a +3 at the end. So which way would this move? Up 3.
Wow.
All right. This one now has a -5 in the parentheses. That's kind of like our H value. Very good. Right 5. Okay. Now, this one has a -2 and then a -1. Well, this is in our H value. This is in our K kind of spot. So this would be right 2 and then down 1. Because remember the H, that's the crazy one. That's the opposite thing. What the heck was that? My screen just changed for a second, went back. All right. And then for this one, kind of the same thing but different. Now we have a plus 1. This means to the left 1. And it's a minus 4, so this would be down 4. Now, we could go a lot deeper into this and make this really super duper confusing, but I don't see the need for that. Okay? I don't see the need for that. I like this. This looks good to me, and we're going to go from there. Okay? Because this is, believe it or not, this right here gets exactly what I would need from for you to understand what's going on here. Okay. All right. Everybody okay? Kind of looks. Look, don't get lost in the fourths and the fifths and the sixths and stuff. Kind of think about it like what we had with quadratics. And then you're like, oh, that makes more better sense. Maybe. I don't know. Some of y'all, your brain was full yesterday and you're just in like attendance mode for the next 2 days, including today and tomorrow. You're just here just to be here. Okay. Attendance mode. All right. Now, I could read this to you, but it's not a really good story, so I'm not going to do that. Okay. Basically, we're asking, it's saying, hey, what happens if you plug this in? Now, what's kind of funny, there's this rule, and we've basically already covered it when we were talking about the end of the behaviors of the graphs, where you're supposed to put it in like a -1 to see if you get like a negative number or something like that for all these exponents to see if it's even or odd. You could look at the power and tell me if it's even or odd, the highest degree. So we're not going to do something like that. All right. I'm not really big about writing the rule. I'm wanting to actually get this right here. Okay. I'm wanting this answer part. If this is our original problem, and now we have x plus 2 in the parentheses, well, we know it kind of went left too. Okay. So this is actually what we would have. X plus 2 to the 4th power plus 1. That's all we did. We just inserted this right here. That's this color. Okay. We just plugged it in. Yeah. Now, yeah, it says 17 through 20. I did have more, but then I was like, no, 2 would be good. That's exactly what we need to get and move on. Okay. So now this one, this 3 is all the way out here in front. Okay. This is actually a stretch of 3. Remember, it's when it's out in front, that's like our A value. Okay. So basically what we would need to do now is we would take 3 and we would multiply it by this original problem. All right. So 3 times this, 3 times this, and 3 times this, which is 9. Some of y'all are like, well, this seems too easy. You're like, some of y'all are waiting for it to get exponentially harder. Okay, it kind of doesn't. Okay. Yeah. There's not a whole, I know you're looking at the back like, wait, we're not doing more on the back of this. Look, we're going to do so much with transformations about different things throughout the semester. I just want to hit the high points. Okay. There's no reason for us to go really deep into this because we're going to end up getting deeper and deeper into those AH and Ks and those transformations as we go through. Okay. Now, this part right here, this 3 through 6, this is going to be the last section. Bless you. On the test. Okay. I had originally thought about having you graph it, and then I thought about my absolute disdain for trying to grade graphs of students, and then so I was like, let's find some matching. Okay. Now, as we were finding yesterday when we were solving stuff, solving polynomials by factoring, these are our x-intercepts. So what's the opposite of -1? +1. What's the opposite of -2? What's the opposite of +2? -2. So I'm looking for the graph that has x-intercepts at 1, 2, and -2. Which one of these four graphs has x-intercepts at 1, 2, and -2? This would actually be A. Yeah, you found -2, -1, 1. Yeah, because see, this is at -2, this is at 1, this is at 2. So that's what would match here. Okay. Now, also with this yesterday, we had it where, I think the one we had was like x plus 3 times x plus 3 or whatever. And people are like, well, do we have to write that down twice? Well, that's no, you don't. And what that does is when you have it repeated, it kind of shrinks that little hump right there. So for H, we're looking for where it has x-intercepts at -2 and -1. Yeah, so this would be C. So C matches up with number 4. Okay, that's really what I'm wanting y'all to know, because I've already tested can you factor it on the test. This is now, all right, from the factoring, can you get it to like this and pick the right graph? All right. So number 5, we're looking at -1, 1, and -2. Which one would that be? We only got 2 left. It's either B or D. Yeah, it's B. Okay, this matches up with number 5. Okay, that would, I mean, by process of elimination, that would have to mean that this would be 6 would match up with D because it has 1 and -2. Well, if we look right here, this is -2 and this is 1. So that's why this would match up right here. Okay. Now, we're going to dabble, like play around on this next part with some graphing these without getting, like, again, really into it. We're basically going to use what we know about the x-intercepts and some other things to make it graph. Okay? Yes. The rocks in the head go rattle, 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 rattle. Okay. Well, I don't know what has happened today. I don't know if y'all are tired or what, but normally we're like picking people up and throwing them across the room. It's like, I, there's something in the water. Oh, they put some like, okay. All right. So now, if I were to ever make you graph one, it would actually look like this. I wouldn't have something out in front of it like number 4. All right. Bless you. Bless you again. Also, there's tissues and hand sanitizers located about the room if needed, because snot happens. So we're going to have dots at this. So I'm going to have one at -3. So the -1, -2, -3. Have one at 1, 2, 3, and 4. Now, I know some of y'all are like, well, what's this supposed to look? This is a cubic. Remember, cubics kind of look like this little curly thing. This is why I wouldn't be like very hard about graphing. As long as it goes through those points, you're good. That's all I need you to do. It does cross the y-axis. I don't know where. I think it actually crosses at 1. Okay. But we're not worried about that. We're graphing with the, let's see. Because it has all the X and Y intercepts. Yeah, let's do this. Nope. Okay. There we go. That's more better. All right. Now, this one has a -4 and a +2. Okay. Yeah, I'm not there yet. 1, 2, 3, 4. 1, 2. Now, it only crosses twice. Now, this is a vertical stretch. Okay. So it's going to actually look kind of skinnier than the red one right here. Okay. So I'm going to make it go. It's close enough. It's hitting the x-axis. We'll say that. Look, here's the deal. Graphing on paper, again, I think is absolutely just archaic. Okay. You could easily go to an online graphing website or something, type in this. You could actually type it in just like this and get the exact graph. Or, yeah, or your calculator. For those that have graphing calculators, there's a multitude of ways to do it without paper. Okay. I mean, the only time I would see in the workforce you graphing on paper, especially for, and this could go through a lot of different occupations, is when you're looking at blueprints and you may have to like mark on the actual paper. You're not actually drawing it out, it's already done. Like it's a blueprint. So you may have to like mark it up like, okay, we need to have this right here and this right here and this right here, that kind of thing. As far as like the days of you sitting there with your fancy lead pencil and compass and protractor and stuff to do it like architects used to do before they actually did blueprints digitally, you would do that, but there's no reason to do that anymore. Yeah. Though, my dad, he, in one of his projects, he actually had to look at um, really old drawings to see where certain stuff was. Good luck. Before they did something, and he says all of it was actually done by hand. and they had photocopied it or saved it somehow, like a picture or some type, I don't know. And he had to like go and overlay and overlay and overlay. So that was it. But that's like they were having to dig in the ground, so they actually had to know like the old original drawings and specs. So, all right, let's see. Let's do purple. All right, this is out here. Remember, any monomial we have, what is that from yesterday? Some of y'all may see it a lot in the grade book. Zero. Very good. Yeah, everybody got that one. All right, awesome. Now, we are going to have a positive 3. So I'm going to write 0, 1, 2, and 3. Now, this is a cubic still, but what about this negative 1 out here? What do you think that does? Yeah, we flip at the x-axis. Okay. Well, instead of going like this, it would go in the opposite direction. Something like that. Yeah, I know. It doesn't look great. I'm sorry. Just look, this is another reason why I used to have to draw 3D drawings on paper in college. Do you know how hard it is to make a 3D drawing on 2D paper? It's not a good time. It's not something that you would invite your friends over to do for fun. It is a lot of erasing. Okay. Now, let's look at this one. Our roots are going to be -1, -2, and 4. Okay. So I can do this, 1, 2, 3, and 4. All right. So this, we have a -3 out front. So we have a negative, so we know it's going to be flipped. Okay. And then it's going to kind of be, it's going to have a vertical stretch of 3. Now, it's hard to actually get that vertical stretch without labeling stuff. We're guesstimating. Okay. So it's going to look similar to this one. So this is going to go here. Almost got it. Okay. Now, is that probably 100% accurate? No. But I did embellish it so it does look like it is actually vertically stretched a little bit. All right. So we're going to do some other things in class. But remember, you hadn't done it yet, hit the like, hit the subscribe, hit the bell. Good stuff, good things. Roll Tide.